This brief lecture is about the types of variables in a causal model. This is all part of behavioral theorizing, which is often tested with structural equation modeling. In this lecture, we're just going to cover the types of variables that you might encounter, and what they mean conceptually and theoretically. This is a causal model. The boxes represent constructs, and the arrows represent effects, relationships, or impacts. So for example, we're saying here that learning is impacted by curiosity. Now each of these variables has a different role and implies a different relationship. Let's start with the dependent variable. The dependent variable in this model is learning. This is the thing we want to predict. It's the final outcome of our theory. It's usually also the central focus of our theory. If we see a problem in the world and we want to try to fix it or address it, we first think, what is the dependent variable? What is the thing we want to fix? And that becomes the focus of our model. The thing that does the predicting is the independent variable. In this case, it's curiosity. We think that this is the primary driver of change in the dependent variable. And what we're saying is that any change in curiosity, or the independent variable, should be associated with some change in the dependent or outcome variable, learning. Next, we have a mediating variable, in this case, discovery. What we're saying is that the reason curiosity impacts learning is because curiosity generates discovery, and discovery impacts learning. So the effect that curiosity has on learning is really because of discovery. Thus, discovery is mediating that effect. It is a mediating variable. You may say that a mediator offers a more precise causal explanation for the effect between the independent variable and the dependent variable. Next, we have the moderating variable. In this case, prior knowledge. This is a variable that contextualizes the main effect. In this case, curiosity to learning. And what we're saying is that the effect from curiosity to learning, while it may be positive in general, may differ based on your prior knowledge of the topic you're learning. For example, those with a lot of prior knowledge or familiarity with this topic may benefit even more so from curiosity, meaning that the effect from curiosity to learning may be stronger for those with prior knowledge in this area, and it may be weaker for those without prior knowledge. Moderators can come in two main forms. One is as a group, such as academic topic, for example, it could be science or math, or as a numerically meaningful variable, such as topic familiarity on a scale of 1 to 10. The way you test these statistically differs, but for now it's sufficient for you to know that moderators come in two main forms, groups and numerically meaningful variables. Lastly, we have control variables. These are the things we need to control or account for in order to place confidence in our main effects. These are also the known confounders or known predictors of the dependent variable. Usually we'd find these in prior literature. In the case of learning, we may think that IQ has something to do with learning, and the higher the IQ, the higher the learning. In this case, we better control for IQ. Often we also control for the usual suspects, such as gender and age. We've learned throughout the years that gender and age and other demographics tend to have some effect on most of our dependent variables. This doesn't mean we always have to control for them. We should only control for those things that should have a theoretical impact on our dependent variable. For example, if we were studying firm performance in revenue, we definitely want to control for firm size, the number of employees, because in the literature we know that revenue is highly impacted by the number of employees. If we want to place confidence in our other effects, such as from our independent variables, we need to control for those known predictors, so that any effect we do observe from our other predictors is unique and beyond that of the effect of the known predictors, or the controls. We decide that something is a control if it's theoretically not very interesting, or if it's already well known and established in the literature. We keep things as independent variables instead of controls if they are theoretically interesting. To review, a causal model contains dependent variables, the things we want to predict, independent variables, the things doing the predicting, mediators, a more precise causal explanation of the reason the independent variable impacts the dependent variable, moderators, a contextualizing factor that may change the effect between the independent and dependent variable, and control variables, the things that are not terribly interesting theoretically, but that we should definitely control for so that we can place confidence in any of the other effects we observe. I hope this has helped you better understand the types of variables in a causal model.